Hello everyone, here are videos for civil engineering. Welcome to the channel Amazing Civil Engineering Studies. Here we have different videos on all topic of civil engineering. Please subscribe and press bell icon, like and share as many as possible. In this video, we will study about traversing, its definition, types, and method used in traverse surveying. What is traversing surveying? Traverse definition. The word traverse means passing across. In surveying, it means determining the lengths and directions of consecutive lines. The linear measurements are made with tape or chain, and the relative directions of the lines are measured with a compass, theodolite, or chain. Direction provides an measurement of distance, the essential two-dimensional data for determining the land area and for delivering horizontal control, i.e., the relative location of points in the horizontal plane. The results of a level network for the same location, when added to this information, provides. The results of a level network for the same location, when added to this information, provides a three-dimensional representation of a section of the Earth's surface. A traverse, in general, is run to locate the features already existing in the area to be surveyed or to establish points or lines by predetermined measurements. Traverses are classified as either open or closed. Type of traversing surveying. 1. Open traverse surveying. 2. Closed traverse surveying. Open traverse surveying. An open traverse is one that does not return to the starting point. It consists of a series of lines expanding in the same direction. Drawing number 1. As a matter of fact, an open traverse cannot be checked and adjusted accurately. It is employed for surveying long narrow strips of country, e.g., the path of a highway, railway, canal, pipeline, coastline, transmission line, etc. Closed traverse surveying. A traverse is said to be a closed one if it returns to the starting point, thereby forming a closed polygon, as per below polygon drawing. Also, a traverse which ends and begins at positions on the plan is known are also referred to as a closed traverse, as per below trapezoidal drawing. A closed traverse is employed for locating the boundaries of lakes and woods across which tie lines cannot be measured, for area determination, control for mapping, and for surveying moderately large areas. Methods of traverse surveying. The linear measurements can be performed by any of the methods listed in the horizontal method. For ordinary surveying, chaining is perhaps the most common. The direction of the lines can be measured by the techniques discussed in compass surveying and theodolite. The precision usually specified for traversing requires the use of steel tape and the theodolite. However, any other combination of linear and angular measuring equipment may be used. The different methods of traversing are mentioned below. Traverse survey may be conducted as below method. Chain traversing, by chain angle. Compass traversing, by free needle. Theodolite traversing, by fast needle. Plane table traversing, by plane table. Chain traversing, by chain angle. In this method, the whole of the work is done with the chain and tape. No angle measuring instrument is used, and the directions of the lines are fixed entirely by linear measurements. Angles fixed by time measurements or linear are known as chain angles. As per below, figure shows a closed chain traverse. At A, the directions of an AD are fixed by internal measurements AA1, AD1, and A1D1. However, the direction may also be adjusted by external measures such as at station B. Chain traversing, by chain angle, shows an open chain traverse. The method is unsuitable for actual work and is generally not used if an angle measuring instruments such as a sextant, compass, or theodolite is available. Compass traversing, by free needle. Compass and chain traversing, the magnetic bearings of the lines of the survey are T. The length of lines is measured either with tape or with a cane and measured by a compass. The direction of a magnetic meridian is established at each traverse station independently. The method is also known as free or loose needle method. A theodolite fitted with a compass may also be used for measuring the magnetic bearings of the traverse line. However, the method is not so accurate as of that of transit tape traversing. The methods of taking the details are almost the same as for chain surveying. Traversing is that types of the survey in which several connected survey lines form the directions, and the framework and lengths of the survey line are measured with the help of an angle, or direction, measuring instrument and tape, or chain, respectively. It is known as a closed traverse when the lines form a circuit which ends at the starting point. If the circuit ends elsewhere, it is said to be an open traverse. The various methods of traversing have been dealt with in detail in units of angle measurement. An angle is a difference in directions of two intersecting lines. There are three popular systems of angular measurement. A. Sexagesimal system. 1 circumference equals 360 degrees of arc. 1 degree equals 60 minutes of arc. 1 minute equals 60 seconds of arc. B. Centesimal system. 1 circumference equals 400 grads. 1 grad equals 100 centigrads. 1 centigrade equals 100 centigrads. C. Hours system. 1 circumference equals 24 hours of time. 1 hour equals 60 minutes of time. Theodolite traversing, by fast needle. In theodolite traversing, the directions are measured in the form of bearings, deflection angle, angle to the right, interior angles, or azimuths using a theodolite, and distance with a tape, electric distance measurement, EDM, equipment, or by a tachometer. Bearings are measured by theodolite fitted with a compass by loose needle method or fast needle method. If the angles measured by deflection angles method, angle to the right, traverse, they are called deflection angle traverse. It is specially used in an urban survey where triangulation is not possible. The theodolite is an intricate instrument used mainly for accurate measurement of horizontal and vertical angles up to 10 or 20 depending upon the least count of the instrument. Uses: the theodolite is sometimes known as a universal instrument. The following are the different purposes for which the theodolite can be used. Measuring horizontal angles. Measuring vertical angles. Measuring deflection angles. Measuring magnetic bearings. Measuring the horizontal distance between 2 points. Finding the vertical height of an object. Finding the difference of elevation between various type of points. Theodolites traversing surveying may be of 2 types. Transit theodolite. Non-transit. In the transit theodolite, the telescope can be revolved through a complete revolution about its horizontal axis in a vertical plane. In the non-transit theodolite, the telescope cannot be rotated through a complete revolution in the vertical plane. But it can be rotated to a certain extent in the vertical plane, to measure the angle of elevation or depression. Theodolites may also be classified as vernier theodolites when fitted with a vernier scale. Micrometer theodolites when equipped with a micrometer. The size of the theodolite is defined according to the diameter of the central horizontal graduated circle. For example, in a 10 cm theodolite the width of the central graduated ring is 10 cm. In an engineering survey, 8 cm to 12 cm theodolites is generally used. Plan table traversing, by fast needle. The plane table is one of the oldest surveying instruments. The distinguishing feature of plane table surveying is that field observations and plotting proceed simultaneously. It is very well suited for the survey of detail in the vicinity of theodolite stations and is extensively used to record topographic details in engineering surveys. Thus it is a graphical method of a survey in which the features being plotted are in full view of the surveyor. This is an advantage in many types of surveys in civil engineering, mining engineering, geology, and other disciplines. Photogrammetry is now the principal method for the small-scale flapping of large areas. However, plane table surveying or plane tabling is used as a supplemental method because it is simple and inexpensive. Traversing of plane table survey. Instead of a compass or theodolite, a plane table can be used to conduct a traverse survey. The detail is plotted by offsets as usual. The traverse may be closed, as shown in figure, or open. The detail can also be fixed by radiation or intersection depending on convenience in the field. Orienting is done by backsighting on the previous station before sight is taken to the forward station. The error of closure is determined at a penultimate station without occupying the last station. Intermediate checks are done wherever possible. Thus, if A is visible from C, D is sighted with the alidade against C and its edge touching A. Plane table traversing becomes analogous to a compass traverse if the orientation is entirely by compass. Although not as accurate as an orientation by backsighting, the method is useful for long, open traverses with relatively short sides since compass errors tend to compensate. A small, light form of a plane table with a trough compass recessed into the board is used for such work. It is called a traverse plane table or simply a traverse table. Traverse procedure. The following steps required to establish a traverse. Reconnaissance. Reconnaissance is the preliminary field inspection of the entire area to be surveyed. During reconnaissance, surveyor goes to the field, checks the entire area, and decides the best plan of working. He has to see the suitability and intervisibility of traverse stations. Also, he has to decide which method of traversing will be employed and accordingly, the instruments and accessories that may be necessary. Selection of traverse stations. The basic principle of a survey, i.e., working from whole to the part, should be adopted. A minimum number of stations should be selected. Length of traverse lines is as long as possible. Reduce time and centering effect of the stations. Linear and angular measurements. Distances between stations are measured by tape or chain, or tachyometric method, or electric distance measurings, EDM, instruments like geodometer or distometer. Angular measurements are done by prismatic compass or theodolite. Plotting of transverse survey. There are two methods of plotting a traverse survey. The methods are as follows: distance and angle method. In this method, distances between stations are laid off to scale and included angles or bearings are plotted by protector or tangent of angle or chord of the angle. Co-ordinate method. In this method, survey stations are plotted by calculating their co-ordinates. This method is more practical and accurate. The biggest advantage of this method of plotting is that closing error can be eliminated by closing error and adjustments. When a close traverse is plotted according to field measurements, the ends of the traverse usually do not coincide owing to the error in the measurement of angles and distances. Errors in angles mostly occur due to local attraction. This error is called the closing error. As per below figure, AA is closing error, i.e. AA equals E. Adjustment of closing error by graphic method. In as per above figure, A, the polygon, AB represents an unbalanced traverse. Having closing error equal to E, AA equals EAS. The point on last point A are not coinciding. The closing error AA, E, is distributed linearly to all sides in proportion to their length by graphical construction shown in as per below figure, B, in which AB BC, CD lie EA are the lengths of the sides of traverse AB, BC, CD, D, and EA either to the same scale as per above figure A, or in reduced scale. The ordinate AA is equal to the closing error AA of figure A. Join AA and drop perpendiculars, or parallel lines of AA, EE, LID, CC, BB on line AA as shown in as per above figure B. Thus similar triangles are formed and corresponding error EE, DD, CC, BB are obtained. As per above figure, C. EEDDCC and BB are drawn a parallel of closing error AA, then cut EE equals EE, DD equals DD, CC equals CC and BB equals BB. Join AE, ED, DC, CB, and BA. The polygon so obtained in as per above figure C, represents the adjusted traverse. Bowditch's method. The basis of this method is on the assumption that the errors in linear measurements are proportional to F and that the errors in angular measurements are inversely proportional to L, where L is the length of a line. Bowditch's rule, also termed as the compass rule, is mostly used to balance a traverse where linear and angular measurements are of equal precision. The total error in latitude and in the departure is distributed in proportion to the lengths of the sides. The Bowditch rule is: correction to latitude, or departure, of any side equals total error in latitude, or departure, x. Length of the perimeter of traverse. Thus, if CL equals correction to the latitude of any side, CD equals correction to the departure of any side, L equals total error in latitude, D equals total error in departure, L equals length of the perimeter, I equals length of any side. CI equals L, L/L, and CD equals D, L/L. Transit method. The transit rule may be employed where angular measurements are more precise than the linear measurements. According to this rule, the total error in latitudes and in departures is distributed in proportion to the latitudes and departures of the sides. It is claimed that the angles are less affected by corrections applied by the transit method than by those by Bowditch's method. See the below image. Advantages and disadvantages of methods of plotting traverses. The various methods of plotting a traverse have their own advantages. Plotting a traverse by the method of included angles or directions with a protractor is the least accurate but the fastest method. The most accurate and the best method to lay out a single angle precisely is by tangents. If a traverse fails to close and if the error is due to drafting, the error may be adjusted simply by rotating each line, except the first, slightly and progressively. In the chord method of plotting a traverse, the erection of a perpendicular, in the tangent method, is. The main disadvantage of the chord method is that an error in any of the traverse line is passed through along to the succeeding line. Plotting by independent coordinates is supposed to be a better method since the independent coordinates of the stations do not affect the succeeding coordinates and thus the error, if any, is localized to a particular point and therefore correction usually involves the replotting of the erroneous point only. In plotting with consecutive coordinates, small errors of plotting are carried forward, and in a closed traverse, the closing error due to inexact plotting can be located since the coordinates used have already been balanced. This may be considered to be an advantage, as the cause of discrepancy can be searched for and eliminated. Since errors are not accumulated when plotting with independent coordinates, they are preferred for plotting an open traverse. Thank you. For now, please subscribe, like, share and do not forget to press bell icon.